Hi everyone, in this video I am going to talk about the selection on observables. If you remember last time we talked about random assignments. So the basic idea was that if we have the treatment that's randomly allocated among units, then just finding the beta 1 through simple Euler's regression, we will be able to find a causal effect. But the issue is that in real life, the treatment is not randomly allocated most often. So although it seems really simple, in real life, we can't apply easily. Now we come to the second best scenario, which is called the selection on observables. Selection on observables says that even if the treatment is not allocated randomly, if we can include all relevant covariates into our regression, then still beta 1 will have a causal interpretation. So, what's relevant covariates? Relevant covariates are the ones that if we can control for these covariates, then our treated and untreated individuals will be comparable with each other. If you remember last time, we said that suppose we naively compare non-trained students with trained students. And suppose the end year grade is 4.7, another 3.7. Then if we just naively compare these two groups, then we will conclude that the training actually decreases the student performance. But can we do that? No, because these numbers reflect so many dimensions other than training. It also reflects training, the effect of training, but also it reflects other factors. And these other factors are called relevant covariates. That means that last time we explained this trained and a non-trained student may be different in many dimensions. It could be motivation, it could be background knowledge. So suppose the trained students before was they have a lack of motivation and they have a lack of background knowledge. That's why they were invited into the training program. Although training program at the end may increase or may decrease the student performance, because there are some other dimension affecting the outcome, affecting the y variable in the background. These numbers does not disentangle the effect of the training program, and these are the ones that we need to include into the regression model in order to be able to causally interpret the beta 1. And that's what selection on observable says. If we can include all relevant covariates into the regression model, then even if the treatment is not randomly allocated among individuals, then we will be able to find the causal effect. So this really seems very easy solution to the problem, but again, the problem is that in real life, it is hard to implement. The first one is that these relevant covariates may be hard to observe, like motivation. Can we really measure the motivation of the students? And the second variable, a researcher for the researcher, it's really difficult to come up all the relevant covariates. So we might forget some of the relevant covariates. So just to come up with a list of full relevant covariates is not an easy task. That's why we can call it as a second ideal or a second best scenario, but still it is difficult to implement. And in the next video, I will talk about omitted variable bias, which is much more easy to implement than the random assignment or selection of observables.